Hello and welcome to our holiday special here at the IDS Vision Channel. Today we want to share our favorite AI cookie recipe with you and also want to answer some questions about the IDS NXT cameras and the features Confusion Matrix and Heatmap. Oh, hi George! Nice to meet you! You want to help me to bake some cookies?
Oh, nice! Thank you, Patrick. Why not? And during the preparation, you can help me with my basic reason for coming here. Could you please give me more insights into IDS NXT?
Yeah, for sure. I can answer some questions for you. I would say I do this during the baking activities because these are also questions I think our visitor students have. Even in the baking process, I still use IDS NXT. Once a time we'll use object detection to check and find the right nuts for our decoration. And afterwards, after the baking process and we get the cookies out of the oven, we will do with a classification network, we will check if they are still okay, if the form of the cookie is still fine for us, so that Christmas tree still looks like a Christmas tree, a star like a star, and that a flower looks like a flower.
Cool. Then my first question would be, what is again the difference between classification and object detection?
Yeah, I can also answer what is the difference between classification and object detection. For sure, we will do this. But now I would say we'll start. Let's prepare the kitchen so that we are ready to start. We take the flour. Sugar on top. Put the butter around. Also the right grams you have to use are on the recipe. Okay, that's it. Start. Hey George, can you mix the egg up for later on topping? Thanks.
Okay, I can do that. But actually, I've never done that before. But I'll give it a try.
Okay, now the dough is ready and we have to put it for some hours or the whole night into the fridge. So, as we do not have the time, luckily, I've prepared something. So here, I prepared one. And therefore we will cut now some stars. Trees and flowers. Yes. Put some flour on the board.
Damn! Another one on the floor. Oh, sorry. Patrick, is it bad if there's a little less egg in the dough?
No, George, it's not an issue if there is less egg inside of it. Doesn't matter. It's not for the dough. It's for the topping later on. So here we have tree, flower, and a star. Let's cut some cookies. So now we cut some stars together, George, and I will get rid of the rest of the stuff here for later. Now we have to select the nuts, and therefore I use, as told before, IDS NXT. And I have here an object detection network running, and you can see that it's still detecting the different kind of nuts. So in our case, I want to pick the blanched almond nuts. So I just grabbed them here. This one and this one. So, and put them on the stars for later usage. And there you see what an object detection network is doing. It locates object in an image and it puts a bounding box around it, gives it a name, so that either you on your screen know, okay, this is an almond, this is a walnut, or this is a cashew. And if you bring it to a typical industrial application, you could say, okay, now I know the object, for example, on my conveyor belt, and the robot has an area where he can pick and he can grab the object, like the nuts in this case, and place it in some bins or something like this. So with object detection, we locate objects inside of an image, give it a position due to a bounding box, and give it a class to name the object. Button it now, let's put the stars into the oven.
Hey Patrick, last week I told my boss about these new features, Confusion Matrix and Heatmaps, and he liked what he saw, but doesn't quite understand yet when to use them. So now, as the cookies are in the oven, we have some time. Could you please explain in more detail what these software tools are good for?
Okay, George, let's start why we do need them. A lot of people feel like it was about AI. They do not trust AI because they only see a black box when AI comes to their mind, and so they do not trust it. But AI is neither a black box nor is it a kind of magic. Basically, it's just math and statistics. To be honest, it is hard to follow this math or this statistics, but with confusion matrices and heat maps, we have the tools to make decisions and reasons for decisions visible and therefore understandable. Let's begin with confusion matrix. When working with a confusion matrix, we run a set of images with known results through the neural network. The results of the decisions are then shown in the matrix. So let us imagine we would like to know how good the neural network is in classifying the shape of our cookies. To make it easy, we use a star, a flower, and a Christmas tree. On the top row, we have to predict the class in the column row, the actual image class. So we feed a Christmas tree to the neural net. The neural net says it is a tree. So we add a +1 into the tree cell. Next image is a flower, which gets detected as a flower. Also a +1 to the flower cell. Again a tree, which gets classified as a tree, +1 at the tree cell. Next is a star, and we get, oh, not a star. It is classified as a flower. So we put a +1 to the star flower field. And so we let the network run and run and run, let's say with around about 30 images. And then here you can see the result. Trees are clearly identified, but stars and flowers are not working properly. So it seems we have to retrain the network here. But where do we have to focus when retraining? That's where heat maps comes into handy. Because the heat maps visualize which image content mainly drives the decision of the neural network. With this in mind, we can now check why the distinguish between stars and flowers does not work properly. Okay, so let's switch on the heat map feature and let's see what the neural network is focusing on. On the background of star or not the star, the outline of star itself. And then, with this information, we can check our training images.
Maybe to identify a data bias?
Yep. So, let's have a look. And here it is. Images of flowers are mostly taken on wooden background and stars on a baking tray. And now we showed the network stars on a wooden ground. And this causes the issue. The network only knows stars on baking trays, and now we showed him on wooden background. And he didn't know this. So what do we learn from this?
That we have to increase the variance of the backgrounds in the images? Yes.
Absolutely right, George. When we are done with the baking, we have to take additional images.
Okay. Last question before we have to take the cookies out of the oven. Where do I activate these nice features?
The Confusion Matrix is currently part of the CNN Evaluator app. This ensures that we can test the net in the real-life environment directly on the IDS NXT camera, with all the characteristics this edge device has. In a further step, the Confusion Matrix will be also part in Lighthouse, so that you can do an early check if your dataset includes biases or something like this. Also, we would have much more calculation power and can use a set of known images there. And the heat maps, they are part of the classification VAP in the IDS NXT camera. You have to activate heat map feature during the training, and later on you have to activate it here in the VAP of the IDS NXT camera.
Sorry, Patrick, to interrupt you, but it already smells so good in here. Maybe we should go to check the cookies. What do you think?
Oh, yeah, I can smell it too. You're right. The cookies are ready. But if they really have to put it up as they should be, we let the AI judge. Now we use a classification network. I trained with some artificial cookies and some homemade family cookies, this neural network, and now we will check if ours we baked here in the AI kitchen are still good as they've done at home. So put it under IDS NXT, and as you can see, it gets clearly identified as a tree. So when we switch to the heat map feature as I described before, let's do this shortly, we can also see why it's identified as a tree, because it's majorly looking at the hard corners a tree have. Those shining edges are the major parts where the neural networks puts its decision on it. If I get rid of the tree here and put a star underneath. Perfect. George, we made it right. It's also identified as a star. And again, in the heat map, you can see that it's looking about all the corners or edges a star has. And this is the major decision for the neural network here. So I could do this the whole day, and maybe to bring it to a point in an industrial application, you can use classification networks to do decisions as, is this element good or is it not good, or does it belong to the type of, as we use it, tree, star and flower, to put it, for example, into the right box. To get back to the example we used before, you could take a robot which grips here the star and puts star into box 2. It puts the tree, and the tree gets here in our nice cookie box, and so on. So this would be in a typical industrial application. Or you could check if there are a star still, or if they are broken and not a star anymore. So okay, not okay. All this can be done with classification networks. But enough talked. let's taste the cookies. Before I put it into mouth, I wish you happy holidays and a healthy start into 2022. Thanks for watching. Goodbye, see you next year. Oh, yeah, good part.